Welcome to the vast cosmos where reality bends. Today on Black Hole Basics, we explore the ultimate shortcut through the universe. Imagine looking up at the night sky and realizing the nearest star is over 4 light years away from our Earth. Even at the speed of light, crossing our own galaxy would take 100,000 years of continuous, uninterrupted travel. The universe is a massive prison of distance, keeping civilizations isolated on their tiny islands of rock and gas forever. But what if there was a secret back door, a hidden tunnel that could connect two distant points in space instantly? This theoretical tunnel is known as a wormhole. It is a concept that has fascinated scientists and dreamers for decades. To understand how it works, imagine the universe is a flat sheet of paper with 2 points drawn far apart. Normally, you travel across the paper, but if you fold the paper, the 2 points touch, creating a bridge across. This pencil represents the wormhole. It is a shortcut that bypasses the normal space between the two distant locations entirely. In our three-dimensional reality, this means bending the fabric of spacetime itself to connect two very distant regions together. The scientific foundation for this idea comes from the theory of general relativity proposed by Albert Einstein in the last century. In 1935, Einstein and his colleague Nathan Rosen discovered a strange mathematical solution within the equations of relativity. They described a bridge connecting two different points in spacetime. We call this structure an Einstein-Rosen bridge, or wormhole. Originally, they thought a black hole could be the entrance, a gravity well so deep it punches through the universe. However, a standard black hole leads to a singularity, a point of infinite density where all matter is crushed instantly. The math suggested a white hole on the other side, a theoretical object that spits out everything a black hole swallows. Unfortunately, these primordial bridges are extremely unstable. They would collapse faster than the speed of light before anything could cross. Any matter trying to enter would be destroyed by gravity, or trapped inside as the bridge snaps shut around it. For a wormhole to be useful for travel, it must be traversable. It needs to stay open long enough for transit. Physicist Kip Thorne later explored this problem. He asked what it would take to keep the throat of a wormhole open. Gravity naturally wants to pinch the tunnel closed. To fight gravity, you need a force that pushes outwards instead of pulling. This requires something called exotic matter, a hypothetical substance that possesses negative energy density and negative pressure to repel gravity. Normal matter has positive mass and attracts. Exotic matter has negative mass and repels, acting like an anti-gravity structural beam. We have actually observed negative energy in the lab. It is known to physicists as the Casimir effect in quantum mechanics. By restricting quantum waves between two plates, we create a vacuum state that has less energy than empty space itself. However, scaling this up from microscopic plates to a starship-sized tunnel requires immense amounts of this negative energy. Some calculations suggest we would need the energy equivalent of a planet like Jupiter to keep a wormhole open. Just 1 meter. Building a wormhole is an engineering nightmare. We must gather exotic matter and weave it into a stable geometric structure. If we succeeded, a wormhole would not look like a flat circle. It would appear as a sphere floating in space. Since space is three-dimensional, the entrance is a sphere. You could enter it from any direction to reach the destination. Approaching the wormhole, you would see the light from the other side. It is like looking through a magical glass window. Inside the throat, gravity might feel strange. Tidal forces could stretch your ship if the tunnel is not wide enough. Moments later, you emerge on the other side. You have traveled thousands of light years in just a few short seconds. This kind of travel would revolutionize humanity. It would turn our galaxy into a connected neighborhood rather than a vast wilderness. But wormholes are not just shortcuts through space. According to relativity, they are also shortcuts through time itself. If you move one mouth of a wormhole at high speeds, time dilation occurs. The two ends become synchronized to different times. This creates a time machine. You could enter one end and emerge from the other side in your own past. This introduces dangerous paradoxes. If you travel back and prevent your birth, how did you exist to travel back at all? Physicists call these closed time-like curves. Many believe nature forbids them to protect the logical consistency of the universe's timeline. Stephen Hawking proposed the chronology protection conjecture. He believed the laws of physics would destroy any wormhole that allows time travel. Vacuum fluctuations would build up in an infinite feedback loop, collapsing the tunnel the instant it becomes a time machine. Quantum mechanics suggests microscopic wormholes exist everywhere in the quantum foam, appearing and disappearing faster than we can measure. Perhaps advanced civilizations do not build wormholes from scratch. Maybe they capture these tiny natural ones and inflate them to macroscopic sizes. If we could inflate one, we would need to thread it with exotic matter immediately to keep it from snapping shut. Even if stable, wormholes might be dangerous. They could act as natural cannons, blasting intense radiation from one side to the other. Also, interaction between normal matter and exotic matter is unknown. It might cause catastrophic explosions or destabilize the entire system. Matt Visser proposed a design that minimizes exotic matter. He suggested framing the wormhole edges rather than filling the whole volume. This would allow travelers to pass through the center safely, avoiding direct contact with the negative energy material at the edges. A modern theory called E=EPR suggests a deep link between quantum entanglement and wormholes in the fabric of spacetime. It proposes that two entangled particles are actually connected by a microscopic wormhole. Spacetime geometry is the glue of quantum mechanics. If true, this means wormholes are not rare anomalies. They might be the fundamental building blocks that stitch our reality together. Pop culture, like the movie Interstellar, has popularized accurate visualizations of wormholes based on real equations from physicist Kip Thorne. The gravitational lensing effect you see is real physics. The wormhole acts like a lens, bending light from behind it. Traveling through a wormhole is essentially a journey through a higher dimension, a shortcut through the bulk of four-dimensional hyperspace. This allows us to beat the speed of light without actually breaking the local speed limit. We just take a shorter path. Creating a wormhole requires the energy output of a star. Only a Type 2 or 3 civilization on the Kardashev scale could attempt it. Humanity is currently Type 0. We are still burning dead plants to fuel our rockets. We are far from building wormholes. However, we can look for natural ones. Astronomers search for gravity lensing patterns that don't match black holes or normal stars. Some theories suggest supermassive black holes at galaxy centers might actually be wormholes leading to other universes or distant times. If they connect to other universes, wormholes could be the umbilical cords of the multiverse, linking different realities in a cosmic web. Wormholes are the battleground where general relativity and quantum mechanics meet. Solving them requires a unified theory of everything. Researchers are using quantum computers to simulate wormhole dynamics. We are testing these theories virtually before we can test them physically. In 2022, scientists claimed to simulate a holographic wormhole in a quantum processor, teleporting information through the circuit. While not a physical tunnel, it showed that the math of wormholes and quantum teleportation are surprisingly similar and connected. Before sending humans, we would send probes. Robots could withstand the radiation and tidal forces to map the tunnel interior. Communication might be impossible inside. Signals would be trapped or scrambled, meaning the probe must return to tell the tale. If a probe returned with data from another star system, it would be the single greatest discovery in human history. Imagine a future where you commute to the Andromeda galaxy for work. Wormholes could make the universe as accessible as a subway. But open doors work both ways. A wormhole could allow hostile alien civilizations to invade our solar system instantly without warning. Strategic defense would require the ability to collapse the wormhole on command. We would need a self-destruct button for the gate. Besides travel, wormholes could be energy sources. We could harvest the immense gravitational potential energy found near the mouth. We could even use them for disposal, sending dangerous waste to a dead region of the universe. keeping our planet clean. Philosophically, wormholes shrink the cosmos. They turn an infinite, lonely void into a connected web of life and experience. But for now, we are stuck with the math. We have no exotic matter, and no way to manipulate spacetime geometry. Perhaps the key lies in dark energy. This mysterious force accelerating the expansion of the universe might be related to exotic matter. If we can understand and harness dark energy, we might unlock the negative pressure needed to build a stable wormhole. Scientists also study acoustic wormholes. These are sound wave analogs in fluids that help us test the mathematics safely on Earth. We have actually built magnetic wormholes. They transfer magnetic fields from one point to another invisibly, but cannot transport matter. These analogs are baby steps. They prove the topology is possible, even if we cannot yet bend gravity itself. Science is a game of patience. Ideas that seemed like magic 100 years ago are now engineering realities today. The dream of wormholes keeps the hope of interstellar colonization alive. Without them, we may never leave our local star system. The speed of light is a strict cosmic speed limit. Wormholes are the only known way to cheat this limit legally. Some speculate that if advanced aliens exist, they have likely already mastered this technology and crisscrossed the universe unseen. If wormholes are possible, the Fermi paradox becomes stranger. Why haven't we seen anyone popping out of portals in our solar system? Maybe it is incredibly difficult, or maybe we are the first civilization in the galaxy to even consider trying it. Topology is the study of shapes. Wormholes change the topology of the universe from a simple sheet to a complex donut. In the chaotic first moments of the Big Bang, the fabric of space might have been tangled enough to form natural wormholes. These primordial wormholes could still be out there today, waiting for us to find them and unlock their ancient secrets. Navigation would be critical. You do not want to take a shortcut and emerge inside a star or a supernova explosion. We would need a map of the network, a cosmic GPS system to ensure we arrive at the correct destination safely. The human body is fragile. We evolved for Earth gravity, not the crushing tidal forces found inside a spacetime tunnel. We might need inertial dampening technology or genetic modification to survive the trip through the throat of a wormhole. The study of wormholes pushes physics to its limits. It forces us to question the nature of space, time, and reality. From the Einstein-Rosen Bridge to exotic matter, we have covered the immense challenges and possibilities of these cosmic shortcuts. Wormholes represent the final frontier. They are the ultimate dream of conquering the tyranny of distance and time in our universe. Maybe in 1,000 years, this video will be viewed as ancient history, created by people who could only dream. Until then, we must keep exploring. We must keep calculating, observing, and imagining what lies beyond the veil of the visible. The universe is stranger than we can imagine. Wormholes might just be one of many secrets waiting in the dark. As Arthur C. Clarke said, any sufficiently advanced technology is indistinguishable from magic. Wormholes are the magic of the future. Ultimately, the drive to build wormholes is the drive to connect, to find others, and to ensure we are not alone. Will we ever build one? Or are they forever locked away by the laws of physics? Only time will tell. Thank you for joining us on this journey through the impossible. We hope your mind has traveled to new places today. If you enjoyed this deep dive into wormholes, please consider supporting our channel so we can continue exploring the cosmos. Click the like button if you learned something new. Subscribe and hit the bell to never miss an update from us. Check out these other videos on the screen to continue your journey through space and time with black hole basics. We appreciate your time and curiosity. Your support helps us unravel the mysteries of the universe one video at a time. This video was researched and produced by our dedicated team of space enthusiasts. We strive for accuracy and visual beauty. Where would you go if you had a wormhole? Let us know in the comments below. We love reading your theories. Remember, the universe is vast, but understanding it starts with the basics. Keep looking up and keep wondering why. From the smallest atom to the largest galaxy, Everything is connected. We are just beginning to understand the threads. Stay curious, stay inspired, and never stop asking the big questions about our reality. The answers are out there waiting. This has been a production of Black Hole Basics. We will see you in the next video. Safe travels, explorers. Black Hole Basics, signing off. Goodbye.